is easy to integrate. Another way of writing this is like this. Correct? And if you integrate this, you get negative 1 from 1 to 2. In other words, you get negative 1 of x from 1 to 2. Now if you plug in 2, you get that. Minus, now if you plug in 1, you get this. Negative half plus 1 is 1 half. That's the proof. That integral less than half.
How many people actually got that?
I don't know. But the reason I wrote this question down is because in the homework, not in the homework, but in those supplementary exercises, you had something like this. And all you had to do is kill the 1 to get an integral with this. Remember?
Yeah, we never. I think you explained that to some of the groups. I was too busy working to hear you what you said.
Well, the solution for that was online.
Oh, I didn't know that.
Yeah, well, I told you I would put it online, and I did. Several days before the test. So that's why that was there. And I think this is pretty simple. This is an easy question. This question could have been made much more difficult if I wanted to. But that wasn't the point. The point was, you know, I did something similar. Let me tweak it just a little bit, give you the same type of question. Can you reproduce the result? And that was the point of this type of question. Okay? Whenever you see a problem on a test or a homework assignment, think of what have I done that looks similar to this. Okay? Spend some time finding out. And figure out how you solve that similar one and see if it applies to you. That's how you do it, right? When you see a problem in life, not just math, that you've never seen before, the first thing you want to do is think about what is a similar situation I've been in? How did I get out of that situation? Maybe that'll be useful to figure out how to get out of this situation. I mean, it's the same idea. It's just, not rocket science. Anyway, and all questions were this simple. Yes?
Number 7, part 1, is that the same thing?
I don't know, what's the question?
If f is a continuous function such that interval from 0 to x of f of x of dt equals x sine of x.
Equals?
X sine of x plus integral from 0 to x.
Plus or minus?
Plus.
Plus. Integral from 0 to x of
f of t over 1 plus t squared dt. And it says find an explicit formula.
Find an explicit function, find an explicit formula for f of x, right? That just means find put f of x equals to something. That's all it means. So the problem, we did something very similar to this. Basically, when f is within an integral, how do you get it out? Take the derivative. Okay, derivative of this. Derivative of this. Product rule. Yes. Sine x. Plus x over 1. Plus derivative of this. No, over 1 plus x squared. Replace every t with x. That's the point. Okay. Now you've got to solve for f of x. So move everything that has f of x on one side, right? So if I subtract this quantity on both sides, then I can factor out f of x. Then I get 1, which is the coefficient of f here, minus the coefficient of f there, equals sine x plus x cosine x. And then I can just divide by this bracket, and I've got f of x in terms of x. Yes? Yeah. Is this clear?
Yeah.
Is this hard?
No.
How many of you got this? 4. Next question.
Question number 2. I think it was getting the fundamental theorem.
You use the fundamental theorem in almost every question on this test. This is fundamental theorem.
Okay, it was the integral from x to x of 3x.
Of 1 over t dt. Yes. The integral of 2x to 3x of 1 over t dt. And you want, this was like f of x. And you want to take the derivative of this, right? Okay, to do derivatives of integrals, the lower limit of integration has to be a fixed number, a constant, yes? Okay, so I could make this equal to the integral from 0 to 3x of 1 over t dt. Maybe not 0, maybe 1. Minus the integral from 0 to 2x of 1 over t dt. Maybe you don't get this from the first try, but you get, because if you do, right, the integral from 2x to 1 plus the integral from 1 to 3x will be the integral from 2x to 3x, right? You just switch this around, you get a minus. Anyway, now the constant limit is at the bottom, just like we want. Now you do the derivative. The derivative of this integral, you plug in 3x for t, multiplied by the derivative of the inner function, because this is a chain rule situation, right? Times 3 minus, same thing here, 1 over 2x times the derivative of 2x, which is 2. You get 0. Right? Because that's 1 over x minus 1 over x is 0. At wx. Next question. What does it say?
Find the number mean such that the line y equals to divide the region.
Okay, yeah, I know that question. Is bounded by these two curves, right? Okay. So you draw a picture. When you draw a chord, these 2 points are not hard to find. That's -2 and that's 2. Yes? That's y equals the chord. You have some area here. You want to cut it in half. Okay? Which is not hard. You can cut it in half like this. Right? But we're not allowed to do that. We have to cut it in half like this. Which is a little more difficult. Yes? Okay, that's y equals to b. You want to find the b so that this line will cut this in half. Yes? Okay. Well, let's first find out what these points are. To do that, you just set the curve equal to the line. And the 2 points you get are negative square root of b and positive square root of b. Is that part clear? Okay. Now, to say that this line cuts this area into half is like saying, if I call this, it's like saying that the area in here times 2 is equal to this whole area. Does that make sense? Let's say that one more time. To say that this line cuts the area into half is like saying 2 times this area is equal to the whole area. Yes? Alright, so let's write that down. 2 times the area at the bottom. Top curve minus bottom curve. Top curve minus bottom curve. That's the area here. It's supposed to equal that whole area, this orange part. That orange part is the integral from -2 to 2. Top minus bottom. Top is 4. Bottom is the parabola. Dx. Okay? Yes? Everything is symmetric. Everything is symmetric. So if I just focus on this part, just this part, right? It's like saying that this little area is times 2 is equal to this whole area, yes? Because of symmetry. So I can change this and write 2 times the integral from 0 to square root of b, b minus x squared, dx, is the integral from 0 to 2, 4 minus x squared, dx. Okay. Does that make sense? Okay. Now let's integrate this then. Integral of b, that's a constant with respect to x, is just dx. Integral of x squared is x cubed over 3. From 0 to square root of b equals 4x minus x cubed to the 3 from 0 to 2. If you plug in square root of b here, what you get is 2 times b to the 3 over 2 minus, if you plug in b over here, you get 1/3 b to the 3 over 2. Is that clear? Now minus, if you plug in 0 for x, you just get 0. So we can not write that. Similarly here, if you plug in 2, you get 8 minus 8/3. Okay? So if I divide by 2, I just get this minus this is 2/3 b to the 3 halves, right? It's like 1 minus a third, so 2/3. Divide by 2, you get 4 minus 4/3. Multiply by 3, at this point we're doing algebra, to remove the fractions. So then, this is 8 divided by 2 is 4. We get b to the 3 halves equals 4. Yes? Square both sides. You get b cubed equals to 8. Oh no, 16. And then take the cube root of both sides. b is cube root of 16. Of course, there's a much nicer way of writing this. It's 2 cube root of 2. But this would be okay. Yes?
Could you possibly do it the other way where you integrate with respect to y and then divide from 0 to b plus b to 4?
Yeah, there is a way to do it that way, sure. Were you asking me to try that? You should try it and show me. Next question.
Number 4, the acceleration function in meters per second squared. A of t equals t plus 4. If v of 0 equals 5, find the velocity at time t and the distance from the interval of 0 is less than or equal to t is less than or equal to 10.
Okay, but you want the velocity as a function of time first, right? And then you want the distance, right?
Do you use stuff from chapter 3 or purely chapter?
Oh, you use stuff from the beginning all the time. But you can do this primarily using the net change theorem, right? The net change theorem says that the net change of velocity is the integral of the derivative of velocity, right? You remember when I wrote all those things down? The net change in population of bees is equal to the integral of the rate of change of the population of bees, right? So the net change of V is the integral from 0 to t of d less dx. You just have to change it. These shouldn't match. Okay, but that's how much the velocity changes over that time, right? That's the net change of velocity, right? To figure out where the velocity has landed, you have to start from where it was. Where was the velocity in the beginning? 5. This is kind of the same thing we did in the honeybee population in your homework. We said it starts with 100 bees, right? The rate of change is r. What's the final number of bees after 10 weeks? We said 100 plus integral from 0 to 10 of the rate of change of whatever quantity you want. The quantity we want, sorry, this is prime. The quantity we want was v. So to get the net change in v, I have to integrate the rate of change of v. Yes? But this is exactly the same as this function. That's the rate of change, right? So that's what's for. Okay, so when you do that, you get 5 plus s squared over 2 plus 4s from 0 to t. So v of t, if you plug it in, t squared over that answers that question. And the question is now find the distance traveled, right? Over which interval? 1 to 6? When you're calculating distance traveled, you have to do absolute value, right? So it's helpful to see when this is equal to 0. The best way of seeing that is to factor out half. So you can have a polynomial that's easy to work with. After looking at this for a little bit, you should agree that this is never 0. This is always positive. Yes? So in order to calculate the distance traveled, all you have to do is integrate the absolute value of this, but you really don't need an absolute value because it's always positive. From 1 to 6, half t squared plus 8t plus 10. And then you get some number. Okay, that's the distance in meters that the object is traveling. Okay?
Can you do the one with generated parabola? I don't remember the equation.
This one? Is this the yeah, okay. And the other one was y equals to x. Okay. Now, in case you forgot, this is how you graph this. You isolate y squared. Okay, and another way of writing this is okay. If you write it this way, then you can see that the vertex of this parabola is 3, 0. And it's a y squared parabola, which means it opens left or right. But since the coefficient of y squared is negative, it opens to the left. In any case, the graph looks something like this. Here's 3. And this is how it opens. Okay? Y equals x is basically this line over here. So the area we're talking about is in here somewhere. Okay. Now you've got to find these points of intersection. And you do that by making, by equating the x's, okay, or by using substitution. So if you just use substitution in here, just basically instead of y, you put x, and you'll see that you get 4y plus y squared equals 12. So y squared plus 4y minus 12 equals 0. And if you do the work, you see that y is negative 6 and y equals to 2. And that tells you that this is negative 6. This is positive 2. To decide if you want to integrate with x or y, you have to decide if you have a top-bottom situation or left-right, right? But you don't have a top-bottom situation because if you draw the rectangle here, the top function is the line, the bottom function is the parabola. But if you draw the rectangle here, the top function is both the parabola at both ends, right? You don't have a top minus bottom situation. You have to do the other way around. So you decide to draw your rectangle horizontally. Okay? Where you draw it there, or here, or here. In any case, it's always the right that touches the curve for any place in this region, and on the left it touches the line. Okay, but in order to do that, I have to solve for x, which isn't too hard to do. Now if you take this and you solve for x, you get x equals to 1/4 y squared. I'm sorry. What do you get? You get 3 minus 1/4 x squared. And this represents the right boundary, so I'm going to call this x right. This is x left. X left equals y. So when I set up my integral now, the area is equal to integral of x right minus x
that's number 10.
Okay.
He wants number 8,
Yeah.
because you messed up with the 7, you have 2 separate numbers.
But yeah, that's what I'm saying. I did this in class.
Really?
Look at somebody's notes. It's the exact same problem. But I want to solve this one. How many of you got this one? Well, why aren't you asking about it then? Nobody got it.
It was only 5.
Yeah, but you can't say logarithm. Yeah, you can't say natural logarithm. That's what you're supposed to get at the end when I say, what does this remind you of? And you don't have to get that right to get the points, but I thought it was pretty obvious that this is the property of logarithms, but we can prove this. Okay? We can prove this. And in order to prove something, you basically just have to make this, and this is how we did that complicated problem, right? So we had something with integrals here and something with integrals here. So if I just write this down, this means that 1 to the xy, 1 over t dt, equals integral from 1 to x, 1 over t dt, plus integral from 1 to y, 1 over t dt. Right? Okay. When I want to show that these two are equal, what do I do? Well, I call this big F. Right? Let's say big F equals this, and big G equals this, right? And I show that big F equals big G. This is how we did that other problem, right? And what was our technique? Show that the derivatives are equal, which means they differ by a constant, and then show that that constant has to be 0, so that they differ by 0 so that they're the same thing. Remember that argument we made? Okay, so we're going to do it that way. Yes? So if that's what F is, and remember, F is a function of x, okay? F is a function of x here, so y is just a constant. Similarly here. So f prime of x equals the derivative of this. This is a very easy integral to take the derivative of. Treat y as a constant. The derivative of that, it will be 1 over xy times the derivative of xy, which is y. What is that equal to? 1 over x. Now the derivative of g, we have to do derivatives of this one first. The derivative of this is what? 1 over x. What's the derivative of this? 0. Because y is a constant, right? We're doing the derivative with respect to x. So it's 0. So it's equal to 1 over x. So what do you see? They're equal. So f prime is equal to g prime. That tells me that they differ by the constant. Yes? Now I have to prove to you that the constant has to be 0. Yes? Okay. So I just take an x value. Let's say x equals 1. Very easy value to work with. Because then, what is f of 1? Well, let's see. If I plug in 1 here, integral from 1 to y, 1 over t dt, right? So f of 1 is integral from 1 over y, 1 over t dt. That's f of 1, right? What's g of 1? This is what g is, this whole thing. If I plug in 1 for x, what do I get here? 0. What do I get here? Well, there's nothing to plug in. I just get that number. Yes? So then if I plug in 1 here, I get 1 integral minus the same integral equals to c. So what is c? 0. If c is 0, then f minus g equals 0 means f equals g. Okay. I'll do the same thing for part B. Okay? And what this was supposed to remind you of is a logarithm. Okay? Because log x times y is log x is log y. And log of x over y is log x minus log y. Right? Anyway, if you don't 2, you'll learn that this is actually the natural log of x. Okay? The natural log of x. But anyways, it's a good application of fundamental theorem. I think you probably use the fundamental theorem every single problem in the test. That was the point of the test. To show you different ways the fundamental theorem could be